Cool. So, morning slot. I'm not a morning person, I have to be honest, so I had to get up really early to be in the state of giving a presentation. And I'm really glad to see all of you here, because to be honest, I saw that no one is coming to the sessions in the morning. So Innovate with Cosmos DB, Semantic Kernel, and AI. I know the name is quite generic, and if some of you read an actual abstract, it's also quite generic, so it's not really clear what I'm going to be talking about. Before I will get to that, I will give a little introduction. So maybe some of you already saw me in some different conferences, maybe some on social medias, I'm not sure. But hi, my name is Olena Borzenko. I'm Ukrainian, currently living in Germany. Well, partially in Germany, partially still in Ukraine. I'm a coding consultant, which means that I used to be a software developer before, with the focus in C#, .NET, and now I'm doing cloud applications. Well, basically whatever is needed at the client. They basically most of the time it's coding, doing some architectures, or identifying the problems, trying to fix it with the client. So this is my day-to-day work. I'm also a community speaker and also conference organizer myself. By education, I'm applied physicist, and maybe this will give you a bit more context on why today's session is going to be like it will be. I also love sport, art, and science, so I always fascinated with the ways when the science and art is getting together and how it can be combined with tech. So, what is this about? What is today's session going to be about? When I made the session abstract, I had enough time to actually think about actual use case that I want to present. There is a lot of nice use cases that you can use Cosmos AI, especially in some business solutions. I use a lot at the clients, this technology, and I worked in the aerospace and aircraft industry, for example. We used it widely for different purposes. I also used it in e-commerce, so it always was a really good fit in the technologies. But this is my day-to-day job, and I wanted to do something interesting with those technologies that can keep me having fun, so I'm not going to be bored presenting this. So, does anyone know what it is from the right side of the screen? Yeah, the machine, how it's called. Plotter. You know that because I told you yesterday. That's cheating. Yeah. So this is CNC machine. It's called Big Plotter. We call it like that. This is basically a machine for engraving or wood carving. The laser cutters, they have similar structure. So it's also like the motor is moving around on the release, and you can do something with that. As you can see in the middle picture and from the left side, I was doing some kind of a graphics with that. So I saw this machine, so I got to work with this machine this summer. I got a new hobby. My partner showed it to me and said, well, we can do a lot of interesting and cool stuff. We can do art with that because he's an artist. He's a graphic designer as well. And of course, I was like, okay, I have a new hobby. I want to know everything about that, but in a very short time. So I was like, in 1 month, I was already doing some of my first pieces. So those are my first attempts. When I asked him what I can do with that, he was basically, well, you can do some 3D modeling, then you can extract it to 2D graphics from that, and then you can use a plotter from printing it. He also told me that you can use parametric equations, which that was the moment when he caught my attention, because I'm a physicist and I do a lot of math. I used to do this, and I'm still in love with those subjects. So I regularly, every time when I have some time, I'm either reading a book or I'm geeking out some equations. So he told me, you can do parametric art with that. So in my head, it was immediately, okay, so I can actually take some, for example, physical processes or some beautiful math equations, and I can create some beautiful art with that. So this idea was kind of like set in my head, and it was sitting there for a while, because I also understand that for this, first, I need a lot of time. Second, a lot of effort. But I didn't give up the idea of trying to do something with this plotter. So if you want to do something, you always have to learn. So I had a lot of fun learning new tools that I don't use. I don't need them, and I don't use them on my day-to-day life. So it's 3D Max, SketchUp, which is completely useless for me because I'm a software developer. I had to learn how to use AutoCAD for actual 2D graphic visualization and editing, and Aspire for optimization of all this image, because one of the pieces, for example, 60 by 60 centimeters, you will see them on the next slide, they take about 3 to 4 hours to draw all the lines. So you need to optimize it, because without optimization, it will take 6 hours maybe, or something like that. And then open build controller. So this is kind of like bare minimum what you need to learn if you want to start working with deployer machines. And there is some final results. So I did really simple thing. I just found some basic shapes in 3D Max. I took them, I found the perspective, I extracted these 2D graphics from them, and then I did some actual drawing. So I used acrylic paints on a real canvas, so there's an actual real art, layering out stuff, and then printing the shapes on top of it. I was really happy and satisfied with the result, because in real life, those pieces are hanging now in my workshop in Ukraine, and I'm really happy with that. I'm very excited, want to do more. But that was summer, so somewhere end of the summer, and then a little realization came to me that this has nothing to do with my job, and I cannot keep doing this every day, and my every evening spending on this. All my weekends went to that. And I had a little break between the clients, so that was all right. But the moment that I started working again for the client, that was taking way too much time. My not just free time, but also like working time. So I like to obsess about things. And the idea of becoming an actual artist, I had to give up this idea because I have an actual job, and I had to find a way how I can combine it with technologies. If I want to do something nice and cool that brings me fun, I have to find a way how I can actually then use it in a daily life and then, well, apply it in my job. So what's the plan? What I'm going to do with this? This is R, there is some parametric R, there is a plotter involved, there is some technologies, and from the name description, you already know that there's going to be Cosmos DB and AI, so I'm going to do something with LLMs and semantic kernels. So just on a conceptual level, I'm going to explain what's the demo going to be about in the end. So as a user, doesn't have to be user. Actually, that can be also an environmental data. For example, IoT devices getting the temperature or the humidity level in the room. That also can be data. Whatever. So there is no restriction on the input. And I have my little web page. I have also exposed API that I can use with IoT devices again. So I'm sending the request with some data, with some user input. Can be random, can be temperature 25 degrees, can be mood set and color scheme blue, for example. I can say I want to see shapes, circles, squares, doesn't really matter. So taking this input, I'm going to go to LLM. So I'm going to have an AI project. I'm going to deploy a few models there. I'm going to go to GPT-4 and say, wrapping this data in a custom prompt. So I'm saying like, you are a graphical artist and you have to do this and this and that. I want this user input to be transformed in a description, in our description. So usually they would look like something that you can afterwards feed to DALL-E and get a nice AI rendered image. But this is not what I want to do with this. I'm not going to use DALL-E at all. This is not the focus for today. Having a description from GPT-4 Omni, I'm creating the embeddings. I'm creating the embeddings from the description that I have. I can also do the same with my custom data, with my user data, and maybe with the art configurations later on for similarity searches. So based on those vector embeddings, later on I can say, okay, which art is similar to this description and reuse it for some kind of a learning. So I can tell my program to learn from the previous art configurations, from the previous records and descriptions that I got. And then I'm saving all this to a data store. So saving user input and embeddings and whatever other information I need in the same container, in the same document. So I want to keep my data close to each other because I don't want to manage multiple data stores. Next thing. So this is just the one step. I'm going to save it to database, and I'm going to stop on that, and then just show a list of items that I have on the UI, because I don't want to go through all the mapping, function mapping, and like art configuration processes if I don't like a description, for example, if I don't like a title. So what I'm going to do next, if I like it and I think, okay, this can be nice, I'm sending another prompt. So I'm sending another request to LLM, telling that I want to extract a key points from the description that I provide. So I will show you later on how description looks like, but basically I want LLM to process my description and say, okay, I see that there is a warm color palette exists. So I can suggest you to use red and orange and yellow color for your art. And for example, a description may contain, and there is a calm day somewhere on the beach and a sunny weather. So sunny weather will suggest about the colors, and the calm day will suggest about some nice, curvy, calm shapes. So that's what I want to get from LLM, because I don't want to do this. I don't want to get just like picking out the words from the description. I want LLM to process it and tell me some nice suggestions of what shapes to use. And I was saying, so parametric art, this was the key thing that was sitting in my head. I wanted to use algorithms for the art visualization. There is so many amazing and nice algorithms, and I went in such a rabbit hole when I was preparing this demo, trying to select few of the algorithms that looks nice, but there is really big amount of those. After presentation, I said, well, I'm not gonna throw this demo away, and I'm probably gonna keep working on it as making my pet project, because I really had fun with this. So you can have ready and complete algorithms that are gonna draw you a really nice, interesting result. Some, for example, leaves, shapes of a tree, or some graphics, some fractals, and that kind of stuff. So, but to use those functions, I also need to somehow map them on the output that I got. So getting some information about what shapes I want to use, what colors, and what functions might be a good fit for my art, I'm also storing in the data store function configurations. So I'm basically saying draw smooth curves, that's the name of a function, and the description of what this function can be a good fit for. So I'm wrapping the function name in the prompt, I'm saving those to databases, so having the list of them accessible for the future function mapping. So afterwards, having that, the next step is to do this function mapping or matching of my description on existing functions that I have on the UI. Well, I just wrote them in JavaScript, and then I can use P5.js for actual visualization. So I hope I still have your attention, because it's kind of like a couple of steps that might be confusing. We will see all of it in the code and how it actually works in the end. But the idea is that I wanted to give custom input and be surprised from output, because I don't want to decide how the final visualization would look like, but I want help from LLM. So that's the steps. This is the concept that I'm going to use. Before getting into code itself, I'm just going to give a quick introduction on actual core components that are going to be in the session. So let's quickly talk about Azure Cosmos DB, what it actually is, Azure AI resources, what is Semantic Kernel, why do I use it. How many of you used Azure services before? Cosmos DB? Okay, so I will give a short introduction. Just real quick, I'm not going to go in too deep. It's just the thing that you can see on the documentation. Azure Cosmos DB, amazing platform as a service, globally distributed, massively scalable, multimodal database service. So I really like using this technology because it offers you a lot of features and a lot of flexibility. It really worked well when I worked with aerospace industry, and we had a single source of truth. So the data, for example, about flights or movements in airports, it's always the same data. Where the aircraft is coming, where it's parking, when it has to fly away. Doesn't matter from what side you look at it, it's either from the airport perspective or from user perspective, it's still the same data, where the aircraft is. So Cosmos DB was doing a really great job in generating materialized views. So we were taking the same data, we were putting some triggers on top of it, on the containers, and we were reacting on every change that was happening in our database, creating different perspective of our data. Basically pre-storing, pre-saving, pre-calculated queries. So you can have multiple data models, which is also this is also the reason why Azure Cosmos DB is used for polyglot persistence approach or architectures. You can have multiple APIs, as you can see. So it's like MongoDB is compatible with actual MongoDB. If you want to have a smooth data transition, this is the way to go. Table API, Gremlin, Cassandra, and default one is NoSQL. All the features are always available first at NoSQL API. For now, for example, vector capabilities available for NoSQL and for MongoDB, but partially. Vector search is not available for MongoDB yet, but you can store vector embeddings in MongoDB with MongoDB API. All right. So very quickly about the actual database structure. You create an account, you select which API you want to use. You cannot change it afterwards. Depends on which API you use. You're always going to have, well, regardless which API you use, you're always going to have container in a database with items, triggers, stored procedures, scale and settings, and user-defined functions. This is the same for all the APIs. But depends on API, the items in the container are going to be either documents or nodes or rows or edges. So, of course, because the different API works with different data models, the item's going to have a different structure. If we want to use a vector search, so if we want to store our embeddings, we have to do configuration of a container beforehand, and we cannot change it afterwards. I will show on AI how it looks. Also, the feature of vector search and saving vector embeddings is not available by default. You have to enable it, but it takes just 1 minute of your time, so you don't have to actually register for the preview. Yeah, so and as I already mentioned, Azure Cosmos DB, amazing platform as a service, because it also has integration with different services. I often use Cosmos DB, and then I put some triggers using Azure functions, either triggers or bindings, or, for example, service bus is always a good combination with Cosmos DB, so I can use it together as well. I can have the real-time processing of data. When I was working at a logistic company, we had to analyze our data very quickly in real time. So if you use, for example, Apache Spark, you can connect to the Azure Cosmos DB nodes in the background, extract the data, and have a real-time data analytics. And the zero downtime migration, I used to get the question at the conferences, what if I want to change the database and move somewhere to different data storage? I think this is just by default question when you choose in any database. So it's very easy to do with Azure Cosmos DB because of a change feed feature. You can connect to the change feed and extract all the data that was put in the database or changed at any point of time. So basically, it offers you event sourcing out of the box. So this is pretty cool, and you can just migrate it either to different container, different Azure Cosmos DB account, or data lake, storage, or table. Blob doesn't really matter. Your choice. So this is just nice to know about some things about Cosmos DB. So why did I use it? As I already mentioned a couple of times, but I'll just repeat it again. So flexibility with data model. With data models, not only I can store different data now in the same document, in the same container, so I can also use it, I can also access it together. So also, for example, for NoSQL, I'm storing my data in JSON format, which is highly flexible and suitable exactly for my case, for example, having some custom dynamic inputs that I don't want to have a strict schema for this. Integrated vector search. So I can store embeddings. I can use later on vector search, currently only for NoSQL, but later on, so I'm sure I know that the team is working now on integrating this in the different APIs as well. So optimized for AI workloads. Probably if some of you used Azure Cosmos DB, you know that Azure Cosmos DB, the AI database. So it's called like this because all the ChatGPT history is stored in Azure Cosmos DB. They started working together, and it worked out pretty well. So now I often watch sessions from Mark Brown where he explains actually the process, how they were implementing this together from the first days. And of course, scalability and performance. It's globally distributed. It's highly scalable. You can, so of course, also there's different pane options, but you can configure your throughput options, or you can have auto-scaling options. So I can give the whole session just about that, but they also have 5 different versions, 5 different consistency levels, which is also cool to know because this is the only database that have that much. So Azure OpenAI services. Yeah, so it provides REST API access to OpenAI powerful language models. So there's tons of them we can use for different purposes. I'll just quickly go through some of the key points for this service. So it's a fully managed service that integrates OpenAI powerful models. It supports enterprise-grade security, compliance, and scalability, of course. Access models with REST APIs and SDKs, and we will see how we can do this afterwards, later on. Designed to meet compliance requirements, leveraging Azure's robust infrastructure to handle large-scale requests. So the Azure takes from us responsibility for all the infrastructure, and that's what I like about Azure services. And pay-as-you-go pricing, so we can be very flexible and control our spendings. I already mentioned what models I deployed for my project, but just once again, ChatGPT for Omni, and I'm gonna do with this generating descriptions, matching functions, and creating art configurations, and text embeddings 3 large for creating vector embeddings that I'm gonna store in the document. Another key core component is Semantic Kernel. If you read the documentation, there's going to be Semantic Kernel is a lightweight open source development kit that lets you easily build AI agents and integrate the latest AI models into your C#, Python, or Java code base. I like the description that I have on the screen, so it facilitates the orchestration. For me, Semantic Kernel, it's orchestration of LLMs and plug systems and plugin systems, memory storage, and planning capabilities. So the lightweight open source development kit wasn't really clear for me enough when I just started working with Semantic Kernel, so I always think about this as an orchestration tool. So the core features is, of course, AI function orchestration, so easily define and manage AI functions, combining different models and services. Plugins and skills, so you can do a lot with the functions, and you can define functions from methods, you can define functions from prompts itself, but you can do some more complex operations using plugins. For example, if you want to use Semantic Kernel with Cosmos DB. So I'm using Cosmos DB SDK and I have it as a separate service, but you can also implement it as a plugin, and you can give the role of orchestration and managing how you store in this data to Semantic Kernel. So memory management and the planning, of course. So let's go into demo. I wanna just like show quickly everything on the UI. Mostly I want to show the Cosmos DB, how it looks when we want to actually configure the vector capabilities. So I create the... So we go here, we do create... I'm not going to create a new one. So Azure Cosmos DB for NoSQL, we just click create. We don't need to configure anything at that point. We just select which API we want to use. And then once we have the account ready, then we're going to have the database. Well, we will have to create a database and containers in it. OK, so it takes a moment. So what we want to do if we want to use vector capabilities, we need to go to settings and features, and we need to enable the vector search for NoSQL API preview. You just click on it, say, yes, I want to use it, and it's done. Afterwards, you go to Data Explorer. You can do this programmatically, of course, but I'm just going to show it how it looks on the UI so you understand the concept. After you have the database, you need to create a container. And if you want this container to be able to store vector embeddings and have the vector capabilities, you have to go here, container vector policy, and do some configurations. So you provide the path to the vector. You select the data type. Usually it's float 32, for example. You select the distance function. So this is the function that's going to be used for actual vector matching. And then how many dimensions. So you can see the maximum amount of dimensions. This is important for when you select an index type. For example, if you say flat, this is allowed, I think, for like 500 embeddings. This is enough. But if you want to use disk on or quantized flat, it should tell you that you have to have at least 1,000 something vectors, the vector representations of your data. So I'm not sure why it's not highlighting now, but this is also the part of documentation. It's important to have enough dimensions for the index type that you're choosing. So when you do this, when you provide a container policy, the indexes will be created for you automatically, and the final result looks like that. Container vector policy. This is what I set up before for the containers I'm using. So description vectors, flow32, Euclidean distance function. And the indexing policy, they are created automatically. And as you can see, the excluded path is the description vector, and then it says explicitly that this is your vector indexes. So that's all for the configuration itself. For the partition keys, the partition key is important to understand what it is. This is just the property in your document that's going to be used for logical partition. So creating the abstract groups of data. And why it's important? Because those logical partitions are being stored on physical partitions, which means an actual data store. And there is no guarantee that all your logical partitions, so your whole data from the same container, will be always stored on the same data in the same data center. There is no guarantee. They can be distributed across multiple data centers, and that's why the selecting correct partition strategy is very important. So you avoid cross-partition querying. You avoid querying multiple data centers. There is not much to do on the actual Azure AI Studio. We just created a project and we deployed 2 models. As I said before, GPT-4 Omni and embedding 3 large. There is some if you develop in locally, there's some configuration that has to be done with the permissions and also authentication, because when I was accessing Azure Cosmos DB, I had to define some permissions. So there is documentation, and it's pretty details on the Microsoft documentation. You have to go step by step executing some scripts to actually properly assign the permissions that you can then afterwards, for example, use it locally. But yeah, it's not a complicated step. But when I first ran it, I was like, oh, hold on, what's going on here? Why it's not working locally? So the permissions, define roles for the Azure Cosmos DB, and you will have to also assign the correct role for your Azure AI resource to be able to use it. Yeah, let's have a look at the actual. I hope everyone uses C#.NET. Everyone understands this. Okay, perfect. So this is a very simple API. I have a few endpoints exposed. And so first one is just to save user data. So I have my user input. We will see on the UI how it looks like. The second endpoint is to get art titles, just to show it on my UI. And then get our art function for actual getting art configuration that I want to display afterwards. And yeah, that's how it looks in the end. So one endpoint I'm using to put my data. Second endpoint I'm using to extract this, show those titles. Third endpoint I'm going to use if I click, for example, one of the items. It takes a bit of time because I didn't really do any performance optimization yet, but it should extract if my application is up and running, of course. Yeah, so it should extract some data, get actual functions, and then show it on the UI. So going back to the code, let's just see what's happening if I say, okay, I have a happy mood, and for example, where it doesn't really matter what I'm putting. If I save my data, I just want to walk you through what's going on here. So save save user data. I have the art data processing service. So the service that is actually responsible for all the operations with the art. So what I'm doing here, so I'm parsing whatever I'm getting there. I'm creating the generate art description async. So Semantic Kernel takes all the hassle for generating that, and then afterwards I'm creating the embeddings, and I'm saving this to Cosmos DB. So just 3 steps in one method. So what do we do here? Generate art description. As I mentioned, I'm using just functions created from prompt. This all can be done using plugins, or you can move this logic in the methods, and you can also create functions from methods. It's all available. For me, prompt was more than enough because I had my art description prompt. So that's how it looks like. There's a bit of a text, and I had to set some guardrails and what I want to get actually as an output. But you creative assistant specializing in generative and algorithmic art, yada yada, take my input and do this. generate me a response. So I want to have a short title, and I want to have a brief description. When I first time used it, and I didn't actually set the proper guardrails and limitations, it gave me like the full page of a really detailed description with some function examples in JavaScript and yada yada. It was great, but I'm like, yeah, I don't really need that. I'm not gonna execute all this text, all this code. So I made sure that it's short and to the point. Yeah. So it's a very simple execution. I'm just providing the function itself, kernel arguments. So I'm providing my user input, and I'm sending this request to LLM. I'm getting the response, and I'm sending this response to the one that I just get to generate the embeddings. It's the same thing. I'm again telling the kernel, because the kernel has the configurations of what models to use. If we will have a look at here, at this one. So my kernel, I'm creating create builder, and I'm adding Azure AI services. So Azure OpenAI chat completion, Azure OpenAI text embedding generation. I'm providing the names of the deployments, the endpoints, and credentials. So, and I'm using this default Azure credentials. If we use this approach, that's when we need to configure the permissions and the role definitions. So our kernel knows, my kernel knows which embedding models to use and how to do the request to LLM to actually generate something. So we're getting the embeddings, we're getting back to the response, and we're creating the art data, and we're saving this all to Cosmos DB. The result looks like that. So I also send a request there, as you can see. So this is the one that I just sent, mood happy, color red. Evoking a sense of pure happiness, this artwork radiates the shades of red from bright to cherry to deep crimson. Circular shapes dominate the canvas, and yada, yada, yada. That's what I wanted. I wanted to know what shapes I need to use. I wanted to know what colors do I need to use. Saying there is algorithmic art actually helped LLM to provide me meaningful result. And then there is my vector definition. So I can use this later on in a code. For example, I can use this for similarity search. Excuse me. Yeah, I switched the theme to white, and I don't recognize my own code. So if you want to do some similarity search, that's how it might look like. So this is very simple query, and this is one of the examples. Basically, I think Mark Brown wrote. So I took the example from there. You take this, so you select some properties, and you use the vector distance function for finding the items, so basically comparing the items to provided vectors. Then you can order them by vector distance, so they get most similar, most relevant, and the rest of the items. So I would use this. I didn't do this yet. I didn't implement this functionality yet, but I want to use this for finding similar art configurations and making art more complex later on. So. Yeah. So this is how it looks like, and when I afterwards when I have my when I have my item created, if I click on it, what's going on afterwards? I'm doing the matching of the functions. So I go to our data processing service, and I have a different method for actual. Oops, sorry. Yeah. Yes. So get art function configuration does this thing of first it extracts the items that I selected just for more details to know what's description and get the vector embeddings. Afterwards, again, I'm calling Semantic Kernel service to generate art configuration. And art configuration is, again, something that I'm generating using prompt. So art config prompt, and if you will look at that one, it has this strict So the strict format that I need. I want to get shapes, patterns, and colors from the description that I provided, and there is some prompt that I'm wrapping it in. So here we go. I'm executing this, and I'm getting the result. With this result, I'm going back. I'm getting the list of all the functions, and the functions look like that. So I pre-populated them to Cosmos DB just to make it easier for now. But this is the function. So the name of a function, the parameters that I need. So iterations and colors, for example, or like Barnsley, Fern, it's just the colors. And this is the description. So what it actually does, so LLM can understand if that's a good fit or not. I'm getting this function list, and then I'm do matching process. So I'm providing the context, my functions, the description of all the functions that I have. And yes, if I will have a lot of those, I'm going to have a problem later on, but this is problem for later. For now, I have a limited amount, so I know that I can just extract all of them, give the art configuration, and do the matching procedure with the match function prompt. Again, the output, I have the strict format that I want to have output. I want to get the name of a function and the parameters that lay within the function configuration. So once that executed and I got the response on the UI, that's you already saw, that's how result will look like. So this cheerful radiance, it had the like red colors and a happy mood. So it decided that this algorithm is going to be the best fit for this, and generated me output. So nothing is hard-coded. It's all the decision of LLM. And if I'm gonna just click around on different functions, it's gonna sometimes it doesn't make any sense how it looks. Sometimes it actually looks nicer. Yeah, so basically that's the result that I wanted to achieve for now. You can slightly see it, but it's basically like a water droplets. This is the result that I wanted to achieve for now. For the later on, my plan is to create a much simpler function. So those are complete algorithms, and I don't need those because they're way too complex and it's hard to actually visualize them. What I want to do is to use the simple, like draw the line, draw the curve, draw a square, draw a circle, do this, and then call the same function multiple times, providing the distortions, providing the radius, the colors, so different configurations that can make the art generation more flexible, a bit more, much more steps going to be involved, but then I can have more control over the final result. Well, not me probably, but I'm going to do this with LLM. So now it's only one function is getting executed, but later on I want to extend it and make it more like a generative art thing. And I also need to fix the color scheme because I can see it, you probably cannot see anything there. So yeah, so this is the APIs, how it looks like. Again, I said there's just a multiple few endpoints for posting my data, for getting it, and I don't need those endpoints. I made them just so I can have a UI, and the UI is just a pure JavaScript with the index HTML file. I was way too lazy to use any kind of libraries, so I just made an index HTML, as you can see, very simple UI. And I used, here we go, I used P5.js. So there's also online editor where you can, for example, test your generative art results. I really like playing with this sometimes, and I really like doing some generative art experiments. So I used it here, and then there is a long JavaScript file. I think it has like around 500 lines because it has all the function implementations. So, for example, drag and curve, like draw energy flows. This is the implementation of it. And the rose curve, that's what we saw before. Lisa's curve, yeah. So as you can see, those are complete algorithms. They will, if it's selected, they will draw very similar result because that's how algorithm works, and that's what I want to avoid later on. Is like this very similar result. I want to have more randomness and more creativity in the output. All right, so that's all for the for the demo part, and I think I'm just on time. I have 1 more minute if there is any questions, and I'm pretty sure that we can have like 5 extra. So any questions? Okay. Good, I'm gonna have a sip of coffee while you're thinking. Okay, if there's no questions, then we can connect on Twitter if you want. Thank you very much. Yeah? Yeah. What do you mean? Oh. Oh yeah, no, I was, you know what? I think this is why, the reason why developers never test their own code. Why they are not trusted. I know there has to be color and the color has to be red. But I'm pretty sure I'm giving it to LLM. I mean, let's just try it now. I'm actually curious. Yeah. Mood, what should I put for mood? Not a morning person. Okay. Not a morning person, and the color coffee. That's how we read it. Coffee. Cool. It takes a little. Yeah. Okay. Dark brew symphony. I'm curious to. I'm curious to see the actual art description. Actually, I'm gonna click on it. It always takes a few seconds to actually process this. So I need to optimize it. But what's the actual result? Evoking the reluctant dawn of a non-morning person, this piece melts rich coffee tones with deeper hues of a grounded yet serene palette. You see, it's smarter than we thought. Yeah, so it's actually the result that I expected. It doesn't have really strict dependency, like if it's color, then you should use it as a color. I'm just providing any input and I'm saying to LLM, you're an artist, be creative, figure it out, I don't know. So yeah, it doesn't really look like coffee. But yeah, but again, I'm not changing the background color, so I have to work with that one. I was getting sometimes pretty, okay, I was getting sometimes pretty nice results, especially like the default one. This is a dragon curve, and I really like that one. But if you play around, like you can generate really big result, but I didn't want to, like I had browser heading a couple of times when I was creating the demo. I was like, yeah, I should keep it really simple for the demo, not having any surprises for now. But yeah, that's a good point. Hmm? Yeah, I actually said that you are specializing in generative and algorithmic art. Yeah, I was experimenting with prompts a bit, and then I didn't want to overwhelm it with details because then it's getting really too focused on one point. So when I say, okay, you are doing a parametric art, it will start suggesting me JavaScript code. Like you can do it like this. I'm like, I'm not gonna invoke your code. This is not safe. But yeah, you can actually give a lot of details, and so far it's doing pretty good, pretty well with the outputs I'm getting, giving me shapes, giving me some like, does it have to be like symmetrical or asymmetrical and so on. Yeah. Any more questions? No. Okay. Then I will just get back to this. If someone wants to scan it, Twitter. I mean, I think you can also find me on LinkedIn. Thank you very much for your attention and enjoy the rest of the conference.